How many times am I going to end up talking about sand on this channel? I'm losing track of how many times I've talked about it already. Anyways, today we're heading to the sands of Octopath Traveler. See, when I was walking around this game last, I remembered this place being a little bit, I guess you could say gritty would be the word I'm looking for. It seems that a lot of things in this desert are covered in some very light cloud-esque thing. You have to look closely, but if you stand still for a minute and focus on the screen, you'll notice it too. I'm sure many people would write this off, but I think this is supposed to signify something, especially because we don't see this to as large of a degree in most of the Octopath Traveler 2 desert areas. Perhaps these areas of clouds was an intended choice. We know that the Octopath Traveler art team likes their details. I mean, I can't blame them, I do too. While in the original, they didn't go quite as far with the visual effects as they do in its sequel, I still remember my first time getting to the Sunlands and being stunned at the effects in those areas. This game really knows how to set the scene. But what exactly is this effect? It looks like a hazy light yellow cloud that's appearing over the characters and immediate surroundings. Why include it at all? Let's talk about it a little, because this could conceivably be accurate in the desert. Let's find out what this supposed cloud is supposed to be. So the Sunlands takes place in the middle of a desert climate, hence all the sand. While a desert decidedly lacks rain most of the time, what it doesn't lack is the wind, which would be needed to move around these clouds, as well as cause their formation to begin with. In deserts, we care very much about the wind, since they can result in sandstorms and dust storms which can harm people and property alike. When it comes to winds in deserts, they form the same way winds elsewhere do, but they can be more substantial. Wind is caused by a change in pressure over a distance, known as a pressure gradient force. Many things can cause a change in pressure, such as different air densities. One thing that can change the pressure in an area is a high-pressure system. These high-pressure systems tend to be co-located over a desert. Now why is that, you may be asking? Well, high-pressure systems are associated with sinking motion, or motion that sinks from the atmosphere to the earth below. This sinking motion can aid in the removal of any clouds and keep skies nice and clear. Okay, so what? What does it have to do with the wind and our weird cloud over the desert? Well, the sun heats the air at the surface, which causes it to rise, thereby decreasing its pressure. And quite rapidly at that. As the air near the surface is heated and rises, the cool air from above tries to replace it, which creates a substantial pressure gradient, and thus substantial wind speeds, which will force this cloud to move around a bit. High wind speeds can also be caused by a lack of soil moisture. A desert's definition is that evaporation must exceed precipitation, and that's pretty much it. When evaporation exceeds precipitation, this usually means that we don't have much moisture in the soil. In our case, yes, sand counts as soil, though it's a very poor one. Most plants can't take root in desert sands or have the nutrients needed for plant development. That's not even going into the fact that sand doesn't actually absorb water all that well. If water hits it, it forms bridges between itself and other sand grains. But it's not the best at retaining moisture if it's just a single grain. Sand's very nature stops it from retaining moisture. What happens without moisture in the soil? When this is the case, there's very little stopping the rocks and anything else hiding in the desert sands from flying around. Sand is very loose and liable to be moved if enough force is applied. This may very well be the composition of our cloud, the parts of the desert sands that are light enough to be lifted by the winds. In this case, our force is the wind. If it's strong enough, it can move the particles of sand into the air, especially really light ones. However, many sand grains in the desert are a bit too large to be moved around to form the cloud we're seeing in Octopath Traveler. Sand size can be anywhere from 62.5 micrometers to 2,000 micrometers. To give you a better sense of how small that is, it's about 0.0625 millimeters to about 2 millimeters. While smaller sand particles can be taken up by the wind and form the cloud we're seeing, I have my doubts that the larger ones would be able to do this. I suspect it's not just the sand that's in this cloud that's drifting over the desert sands. But if that's the case, then what else could this be composed of? To find the answer to that, I started looking at the natural processes that can occur in a desert that would result in us getting smaller particles. This is where the wind comes back into play. Not only can the wind transport particles, it can also erode the sediments. Erosion is a geological process in which materials on Earth are worn away and transported by natural forces, such as the wind or water. You may have heard of this process before. It's often discussed when talking about places like the Grand Canyon. The common saying I've heard is that the canyon is never the same each and every day. That's because erosion occurs there, which breaks down the giant rocks into smaller particles. Now granted, it's not noticeable by any stretch of the imagination. It doesn't exactly have any major changes because erosion is very slight, but nonetheless, When there's erosion that happens over the Grand Canyon, it will become noticeable after a long period of time. Basically, erosion forces the sand to break down even further into smaller particles. Since sand at its core is basically small rocks, this process would indeed be able to occur on the desert sands. But what's smaller than a tiny rock? What on earth is smaller than sand? I have an answer. Silt, clay, and colloids. Those three things are all smaller than sand. If you're wondering what on earth are those things, don't worry, that's where I come in. Silt is a solid dust-like sediment that's a granular material, usually comprised of broken quartz. This can be any size between 3.91 to 62.4 micrometers, so smaller than sand. Clay is a fine-grained mineral that's created when rocks break down. Particles of clay are less than 3.91 micrometers, until you get around to be 1 micrometer, which is about the size of a colloid. A colloid is usually a substance that is dispersed evenly throughout a different substance, usually less than 1 micrometer. A potential colloid we could see for terrain's purposes is mud, especially if it is very fine clay. In the Octopath Traveler deserts, I suspect the sand would erode into silt. The wind would then pick up this silt and transport it. If we get large enough amounts, which we see to in Octopath, this is likely what's floating around the deserts. So you might be thinking to yourself, what's the name of this phenomenon? I've never heard of any meteorologist saying silt's floating around. Well, you'd be right, you usually don't say that. We call this phenomenon atmospheric dust. No, I'm not joking, we call it dust, because that's pretty much exactly what it is. I can imagine somebody out there rolled their eyes at what I just said. We commonly think of dust as an indoor phenomenon, after all. It tends to gather on flat surfaces in our homes. So how could that dust be the same dust as what we're seeing in Octopath Traveler? How do we know that the floating clouds we see in Octopath are really dust? I'm about to blow your minds. Atmospheric dust is not the same as the dust we can find in a building, though it is similar in terms of composition. Dust's official definition... I seriously went and looked up dust's official definition. This is how far I went for you all. You're welcome. Dust's official definition by the International Standards Organization is small solid particles, conventionally taken as those particles below 75 microns in diameter, which settle out under their own weight, but which remain suspended for some time. In less technical terms, they're small particles that can float in the air for a while but eventually do fall to Earth. For your reference, a micron, in this case, is a micrometer. I seriously just defined dust. I'm only now questioning what my life has become doing this. So how does atmospheric dust differ from the dust inside a building? Atmospheric dust is typically composed of materials from weathering rocks, eroding soil, gas emissions, and more. Dust within our homes can also be made of these things, but it can also comprise of dead skin cells from humans, dirt that's been trapped inside, dust mites, dead hair cells, etc. At least half of the dust in our homes can be comprised of factors that originate outside, but that amount can vary. I think it's safe to say that dust that hangs out around a house is not the same as dust that hangs around outside. I have doubts that the dust we're seeing in Octopath Traveler all originated indoors, especially given its coloration. It's a light yellowish haze of sorts. I won't speak for anyone else but myself here, but I'm pretty sure most indoor dust that I've experienced in my life is white. If it's yellow, it'd be a lot easier for me to clean, and believe me, I would appreciate that, but it's white as far as I can tell, so not the same as outdoor dust. Seriously though, how cool is it that I found dust in one of my favorite RPGs? Like, how cool is that? I never thought I'd see the day where a video game included dust. What are the odds of that? Apparently pretty good. Thanks, Square Enix. Continuing to give me things to talk about. I always appreciate them. Thank you all so much for watching. If you enjoyed the video and want to see more content like this, be sure to subscribe. I have more on the way. I will see you all in the next one. Have a good day, everybody.